So now we're going to take a look at an interval estimate of a population proportion. And so we're going to have an estimate of a population proportion. And a population, you could have a proportion. So a proportion is just like a certain percentage of, like say we're studying people, a certain percentage of people like this versus that, or a certain percentage of people are this way versus that way. And that's a proportion. So proportions are easy to understand when you think about them out of 100. So like 32 out of 100 people like chocolate ice cream, or 74 out of 100 people like to ski, or 88 out of 100 people are satisfied with their customer service experience. But you could also think of proportions just as any number out of a larger number, right? What proportion? The proportion is the numerator is the smaller number, denominator is the larger number. So you could say that 115 people out of 674, went skiing or whatever, right? That's how proportions work. Or 3 out of 4 people, right? 3 out of 4 people, 75%, came to the football game, whatever, right? It's a proportion. So we're going to have a sample, and we're going to calculate or find a sample proportion instead of trying to do a study on the entire population when we're trying to figure out a proportion about something. Instead of doing a study on an entire population to find out the population proportion, which is represented by just P, and I think we have this in our notes, population proportion, just P right there, right? We could do a sample, and we could get the P with the line over it. We could get a sample proportion, and that sample proportion, we could make an inference about the population proportion. Now the sample proportion will give us a point estimate, and then we could add and subtract plus or minus a margin of error of that. And with a certain interval of confidence, we could say the population proportion with 95% confidence is going to fall in this range, right? So 95% of the time, 95% confidence, the population proportion is going to be in that range. And so we could create that interval estimate. The interval estimate is the point estimate plus or minus that margin of error gives us our interval estimate. And so here is that terminology again. An interval estimate, confidence interval is the range of values, right? And then the confidence level, so the confidence interval is the interval estimate, or aka the interval estimate is the range of values. The confidence level, aka the confidence coefficient, is what kind of confidence do we have? 95% confidence, 99% confidence, and then the margin of error is the plus or minus some amount part. So that's what we're going to see in this video is how do we, what's the general form of an interval estimate of a population proportion. And so it's going to be the sample proportion plus or minus some margin of error. And so here is terminology. And I highlight this stuff because otherwise it's just like a whole big run-on of words. And you don't really understand that, it's hard to understand, at least it was for me, that this is its own phrase, and this is its own phrase, and margin of error is its own phrase. So the sampling distribution of the sample proportion plays a key role in computing the margin of error, the plus or minus part, for this interval estimate. And interval estimate is, we called it a confidence interval, and we called it also an interval estimate. So I'm going to say, ding, that's fair game. They called it an interval estimate there. And I'm being precise about this, methodical about this, because I think there's something in here, if I remember correctly, where they're not using the terminology that's already been laid out. And that kind of irks me because it's just more confusing stuff. It'd be like, you're learning French or you're learning Chinese. Let's just stick French. And you're learning how to say, I want a donut with sprinkles. And somebody else comes along and says, let's go get that deep fried pastry with the little colorful sugar on top. You're like, what are you talking about? I'm talking about a donut with sprinkles. It's like, why don't you just call it a donut with sprinkles? I'm learning the language. Quit giving me a hard time. So that's the bone I'm picking with statistics. So the sampling distribution of the sample proportion can be approximated by a normal distribution whenever NP is greater than or equal to 5 and N times 1 minus P is greater than or equal to 5. So we're going to learn what this is here, but N, we know N already is our sample size, and P is population proportion. So when you take your sample size and multiply it by your population proportion, which is going to be some percentage, some decimal between 0 and 1, because you have a smaller in the numerator by a larger in the bottom, and 0 to 1, 1 being the whole, 100%. You're going to have some percentage, some proportion of the whole. So when we do n by times p, we should have that be greater than 5. And when we do n times 1 minus p, that should also be greater than 5. And again, beyond my pay grade to understand why on that one. So I'm just going to let that one be. So normal approximation of a sampling distribution of a sample proportion is, it's like that. And then here we have, this is the standard error of a sample proportion. And the standard error right there is the standard deviation of that sample proportion. So if we did multiple samples, we're going to get a different proportion in our sample. And then those different proportions are going to, create a normal distribution. And so that normal distribution will have a mean and it'll have a standard deviation. And we call that standard deviation of that, we're doing statistics on our statistics. We call that standard deviation of our sample proportion the standard error, and there's the formula for the standard error. All right, so coming to the next slide, here we have that formula right there, p times 1 minus p divided by n, p times 1 minus p divided by n. Here they're doing it with p without the line over it. Here they're doing it with p with the line over it. I'm going to stick with this one because that's the larger one, and I'm just going to think that one, right? Like, you don't know your population proportion yet, so how could you calculate that? So I think that one needs lines over it. Another error in our textbook, I kind of like pointing them out because it means we're being methodical and we're being thorough. So here we have our sample proportion plus or minus the margin of error, and we're going to have some z-score here for our confidence coefficient or our confidence level, right? So it'll be like a 95% confidence level or 95% confidence coefficient. We're going to have some z-score here. So at 95%, right? 95% means, and I'm just being like repeating this just so you get the repetition, 95% means that 95% is going to be here, and then 5% is going to be in the two tails, which means half of that 5% is going to be in this tail, and half of that alpha, that 5%, is going to be in this tail, and alpha is just the stuff in the tails that's not in this part, which is not in the confidence level, the confidence coefficient, right? So that alpha is out here in the tails. That's going to be 2.5%. So if 97.5% of our data is this way, and it's a normal distribution, we could go to our z table, and at 97.5 we have 1.96 is our z-score. The z-score is how many standard deviations, right? 1.96 standard deviations away from the mean. That's where this point is, right? That's the z-score. How far is a point from the mean? Divided by standard deviations. That tells you how many standard deviations that point is from the mean. That's the z-score. And so there's our z-score. It's 1.96 standard deviations from the mean. Right here, 95% confidence. This point is 1.96 standard deviations from the mean when you have a normal distribution. Okay? And then, right, we know that. So where are we? Where are we? We looked at that. We looked at that. All right, here we are. So this is going to be 1.96 times this margin of error, that margin of error right there. And this margin of error is just our sample proportion times 1 minus our sample proportion divided by n, our sample size. And so here, this is the confidence coefficient, 1 minus alpha. I'm not sure, like, where, I guess 1 minus alpha, like, why did they include this in this picture, right? But like 1 minus alpha is, confidence coefficient, 95% confidence, right? And so 1 minus 0.95 is going, 1 minus alpha, 0.5 will be our confidence coefficient, which is 95%, 0.95. Confidence coefficient or confidence level. I'm not sure why they included that in that slide. I think that makes that slide a little bit more confusing. And then we have z with alpha divided by 2, where z value providing an area of alpha divided by 2 in the upper tail of the standard normal probability distribution. And we have p with a line over it, which is, what do we call it? X bar. We're going to call this p bar, right? And that's the sample proportion. So here is this in action. And so let's say we do a survey of 900 women golfers, and we want to see how they view their treatment at golf courses in the United States. The survey found that 396 of the women were satisfied with the availability of tee times. So I guess they're equating like how they view their treatment at golf courses as whether or not they get tee times. Weird, right? Like it's just not a well put together. Like, you know, I think treatment at a golf course is really different than whether or not there are tee times available. Suppose one wants to develop a 90, you got to think. Suppose one wants to develop a 95% confidence interval. Now, this is the one where I didn't really care for the way they put this together, because a confidence interval, or, the confidence interval estimate is the range of values. The confidence level, the confidence coefficient, is the percentage, like 95% or 99%, that reflects how certain we are that the true population value lies within that interval. So I'm going to come down here to this one, and I'm going to say this is a mistake on the textbook, and this should be confidence level and not interval. So, you know, graduate students who make these slides get tired too, and they use the wrong phrase in the wrong places. And then, you know, even the people who check the stuff before it goes out to the masses overlook stuff. So suppose one wants to develop a 95% confidence level estimate. Confidence level, I'm just going to take that estimate out there, for the proportion of the population, and these are like, you know, unique concepts, so they're highlighted, of women golfers satisfied with the availability of tee times. So that's a different question, right? That's a different question, right? This is like satisfied with their treatment and satisfied with the availability of tee times. I'm going to change this to satisfied golfers, to learn how many golfers view treatment golf course. A national survey was conducted to learn how women golfers view, to learn how many women golfers are satisfied with, and I think there we go, tee times. So I'm just going to take that out because I think that's with the availability. I did spell it right. And I'm just going to make this a satisfied. Now that kind of supposition, what's supposition mean? That kind of supposition there, we'll see if I'm using the right word. Supposition is an uncertain belief. I don't think that's right. Now that proposition, I think that's right. Now that proposition is statement or assertion. A statement or assertion that expresses a judgment or opinion, a suggested program or plan of action. Yeah, that works. So now that proposition, how many women golfers are satisfied with the availability of tee times, this all makes sense. That all makes sense. And so here we are, right? We get all this stuff up here. So here's like sample size is 900. Sample proportion is 396 over 900, or 0.44, or 44% are satisfied. And the confidence level is 95%. All right, that slide's cleaned up. And I need to make that correct. See, even I make errors. So then we take this margin of error and our point estimate, and we get it all together. So margin of error, our confidence level, right? And add that all to, this is all the margin of error. So that is our confidence level times this right here. And then the plus or minus part, so all of this is the margin of error. And that's our point estimate. So n equals 900, this, and this. At 95% confidence, it's 1.96. So 1.96 times all of that, just kind of put in the numbers and do the math. And then plus or minus 0.44, it's this. So we can state with 95% confidence that between 40.76 and 47.24% of all women golfers are satisfied with availability of tee times. Wow. That's statistics, ladies and gentlemen. That's statistics. All right, we got one more little section. It's orange. See you in the next video. Let's do it. Let's get it done.